In this section, we will be considering addition and subtraction of rational expressions, and we'll be considering two types. One with the same denominator and the other one with different denominators where we get the least common denominator. Let's try the first one. You have here 8x minus 7 all over x plus 3 plus 2x plus 37 all over x plus 3. It's a rational expression. Well, basically, and we have a numerator, denominator. So the process here is very similar to the steps in, it's not similar actually, it's the same as adding like fractions, where we combine the numerators either by addition or subtraction, and then we copy the common denominators. So that's what we'll do here. Okay, so let's look at the first one. You have 8x minus 7. We combine that to the other numerator, which is 2x plus 37. We can now put this under just over just one fraction bar, x plus 3, okay? In your numerator, you have 8x minus 7 plus 2x plus 37. Let's combine like terms. Since the operation here is addition, that means we don't have any change in signs. So we combine 8x and 2x. We have 8x plus 2x. Constant terms, we have negative 7 plus 37. All over x plus 3. 8x plus 2x gives us 10x. And we have negative 7 plus 37. What's that? Okay, that's plus 30 all over x plus 3. After adding your numerators, let's see if we can factor. And so we look at those greatest common factor method, factoring by grouping, quadratic trinomial, or special factoring, whichever is applicable. But looking at our numerator, it's 10x plus 30. There are only two terms, okay? So if there are only two terms, chances are that's either a difference of squares, sum of cubes, difference of cubes, but it's not. This binomial can be factored using the greatest common factor. So we look at 10 and 30. What divides 10 and 30? The biggest number that divides 10 and 30, everybody agrees? It's 10. All right, so it is 10. So we factor out 10. Just in case you want to know why 10. Of course, by simply thinking, well, what number divides both 10 and 30, you might be thinking, oh yes, 10. But the process there is simply by prime factorization. We get the prime factors of 10. We have 2, 5. And we get the prime factors of 30. We can start by maybe using 6 and 5, right? And then we still factor 6 because it's still composite. You have 2, 3. So we have this box is for 2. This box is for 5. So we can put 5 here. We don't have box for 3. So we create one. We have 3. When you get your greatest common factor, simply bring down what's common. So what's common to both? 2, 5. 2 times 5, you have 10. Well, if you want to show that process, I mean that step, but that's not required. It's optional. So you may or may not include that. Let's get the factor inside. So what factor goes inside your parentheses? X plus 3. Okay, let's divide. Okay, 10x divided by 10 here is x. And then 30 divided by 10 here, 3. So we have there 3. That's all over x plus 3. Now let's do our favorite thing here. Everybody's favorite, maybe cancellation. So we do cancellation, x plus 3. We can do cancel x plus 3 here. And so our answer is simply 10. That's simply 10. Here's example 2. If you look at your denominators, they are the same. So we call this like rational expressions. They have similar denominators or equal denominators. So we can combine, right? But take note, our operation here is subtraction. We can put these numerators over one fraction bar. We can combine this now. We have 2x minus 1. Let's enclose this with parentheses, especially that our operation is subtraction. So numerators are combined. We can just write x minus 3 once, just under this fraction bar. And then we follow our rule. What's our rule here? That's minus, so we do copy, change, okay? So we copy 2x minus 1. Let's just copy, change that using the subtraction rule. So minus will now change to plus. And we'll change this sign, so okay? We'll change this sign. Okay. What will happen to x? Change all signs of your expression here inside this parenthesis, x plus 2. So x becomes negative x. How about 2? You change the sign also. That becomes negative 2. And that's all over x minus 3. Combining like terms, you have here x, your x terms. Your x terms are 2x minus x. And then constant terms, we have minus 1, minus 2. What's 2x minus x? That's x. About negative 1 minus 2. All right, very good. That's negative 3 minus 3. And that's all over x minus 3. So what is this now? X minus 3 divided by x minus 3. If you cancel it, there's nothing left. What does that mean? Is it a 0 or a 1? Okay, very good. Thank you for giving me that correct answer. Because some put 0. Okay, everything is canceled 0. No, it's not. We are dividing. Okay, so x minus 3 divided by x minus 3 is equal to 1.